Welcome everyone to the EuropeanaTech and AI webinar series. We're going to kick off this series today with a presentation on St. George on a Bike, a project by the Barcelona Supercomputer Center and the Europeana Foundation. This is going to be our first session, but there will be many others. And I will also share the link to the other sessions that we are going to have this spring in the chat later. So before we kick off this session, I'm going to start with some housekeeping rules. So first of all, please note this event will be recorded. So if you want to not be visible in the final recording, please make sure that your camera is off. If you raise your voice, you will be hearable in the final recording. We want to make sure that everyone can take part of this information, so that's why we decided to record the session and to also make it available online later on Europeana Pro as well. So some tips to maximize your participation and to make sure that everyone gets a great experience in this session. Check your username. I'm sorry, I'm hearing some echo. Now it's better. So check your username. If you want to use your first and last name, that makes it easiest for everyone to get in touch with you or to help you also, or we can help you later with questions after the webinar. Please mute your microphone when you aren't speaking so we can just increase the sound quality of this webinar session, and please don't take it personal if I mute you because you might not find the microphone button. If you need to leave for a second and had your camera on earlier, please turn your camera off. And you can of course have your camera on during the webinar, but you don't have to. We use the chat in this webinar session to share thoughts or comments, or even to get in touch with each other. And if you have urgent matters or issues with the experience here, you can always drop a line in the chat. If you want to ask questions, we want you to post them in our Q&A document, and that has a really simple reason, because we want to make sure that everyone's questions gets answered. So that's why we're collecting all the questions in the doc that I'm sharing now in the chat. We will be having a Q&A session later and at the end of this session. And I will be moderating these questions, but we might not have time for all the questions. So that's why we are collecting them in this document that you find right now in the chat. And the speakers will also have the possibility to answer them there if we cannot pick them up in the Q&A. We ask you to follow our code of conduct. I'm going to post that link as well in the chat again, but otherwise you will also find it in the Eventbrite message that you received together with the Zoom link. And there you find also the contact details of Susanna, which is an employee of the Europeana Foundation, who you can get in touch with if you have questions or you want to report an issue regarding the code of conduct or something that you experienced during this webinar. Exactly. That's all the housekeeping that we have to do today. So I really hope that you will enjoy this session, and let's keep going. This is the moment when I try to get to the next slide. Here, EuropeanaTech and AI is a webinar series to explore the opportunities and challenges of working with artificial intelligence in the cultural heritage and arts sector. And it's organized by the EuropeanaTech community, one of the communities in the network of Europeana, of the Europeana Initiative, and with the help of Europeana Foundation. And at this point, I really want to thank Tamara van Hulst and Gina, who have been helping and supporting us with getting this webinar series on the road. So thank you so much for helping us. And I also want to give a shout out to Antoine, Isaac, and Clemens Neudecker, who have been both helping and supporting us to get the series running. And of course, I want to thank these people who are our speakers today. So welcome Barcelona Supercomputer Center and the researchers that have been working in the project St. George on a Bike, and who will introduce us today to their important project. Welcome Cédric B, Albin Larsson, Maria Cristina Marinescu, Joaquim Morel Lopez, and Artem Reshetnikov. I'm really looking forward to your presentation, and I hope you will all enjoy this session of EuropeanaTech and II.
Hi, everybody. I'm Maria Cristina Marinescu. I'm the coordinator of this project, and I'm very happy to be here with you today and introduce our project. Okay. I believe that everybody here in this webinar understands the value of cultural heritage, not only the historical and emotional value of cultural heritage, but also more tangibly, the fact that it can actually foster the creation or the consolidation of a society that has strong values, shared identities, a society that basically by understanding our past, our different but at the same time shared past, it's better equipped to approach the future and hopefully create a society that is more tolerant, inclusive and creative. Okay, to be able to translate this, which is our main motivation, into concrete initiatives such as research or educational, cultural, and social projects, we basically believe that we need to empower people through allowing them to access good quality metadata associated to cultural heritage. And when I mean metadata, I mean in general labels, object labels, tags, and descriptions for what happens in images of cultural heritage. Okay. Currently, this is not the case. Metadata is not at par with what it should be to be able to allow all these initiatives and projects to take off fully. Okay, so what do we do in this project? We basically try to contextualize the objects in an image that we detect in an image and the way they're composed as part of this image, such that we can automatically create rich metadata and this way about that image, and this way endow artificial intelligence with insight on symbols, traditions, and culture. By doing this, we would be able to avoid challenges, issues, problems, whatever you want to call them, such as the ones that you see in the two images to the right. Both of them are paintings of St. George fighting the dragon. And with current tools, and this was one of the motivation for our project. With current tools, we basically, you can obtain caption-like descriptions that say, well, a couple of people riding on a motorcycle or a couple of cats laying on the rock have nothing to do with St. George on a horse fighting the dragon. Okay. So this is what we target. And let's see if this works. Yes. To take on this task, we basically jointly use techniques from different fields, mostly from artificial intelligence, and we apply them to images or to when we have aligned image and text pairs. The techniques that we're using are mostly coming from neural networks, deep learning, natural language-based model, natural language processing, and more recently, things that have to do with semantics, semantic metadata extraction, and semantic reasoning. Okay. What is our main challenge? Well, on the right, sorry, before I go to the main challenge, on the right, you can already take a look at the painting. It's very similar to the ones before. Again, it's St. George on a horse, and it says, a dog is laying on the ground with a dog. Okay, so our main challenge is the following. Current tools don't, well, do a very good job for pictures of everyday things, okay? Because there's extensive data sets of these pictures and descriptions of what happen in these pictures, but they do, well, let's say a spectacularly bad job, apparently, on images that come from cultural heritage. Okay? What we're looking at in this project are mostly paintings from in the range of the 12th to the 18th century, and especially focusing on iconography. So let me just point out I think a lot of you understand this at an intuitive level, but I just want to spell it out a little bit. Why these current approaches, these current tools don't work well for cultural heritage images. Well, first of all, the data sets, the number of paintings around, it's not that great. I mean, it may seem large, but it's not actually very large by data mining standards. Okay. On top of that, there's the context of time that is important. Okay, they're old objects that are not in use anymore, and if you only look at current pictures of current objects, you don't find those objects necessarily, and you see there an inkwell, which is recognized as a blender on a counter. Okay, and an inkwell is not even such an old artifact. Okay. Then there are objects with different shapes in the past. A plow. A plow exists today, but it has nothing to do with what you see in that painting. Sorry, in that picture. That's even a picture, which is identified as people playing frisbee. I don't know how, but that's what it says it is. And then we have new objects that are different, but have similar shapes as old ones. For example, books in paintings are identified usually as cell phones. And then the one last example, unusual actions. Okay? In pictures of everyday activities or whatever, you're not going to see many violent scenes, or if you do, there's certain actions that you're not going to see ever, probably, like man killing a horse. There are some paintings that, anyway, so what I'm trying to say is that the time context is very important. And this, without putting things in context, in time context, it's difficult to do a good job. Third reason, obviously, there's a lot of variety of styles, of medium, whatever, much larger variety than, you take a picture of something, it's going to have the same texture, the same style. Okay, there's no variety. And lastly, there are two other aspects that are very interesting when you look at paintings. One of them is sometimes they depict imaginary beings. I don't know, witches, angels, devils, whatever, things you can't take a picture of. And finally, symbols. This can refer to symbolic objects, but it usually is connected more to symbolic scenes. I don't know, the Annunciation or the crucifixion or whatever. So for all these reasons, current tools don't do a good job. And this is basically how our project came to be, how the name of our project came to be, St. George on a Bike, because of the automatic generation of this description by one of the existing tools. Now, before I go on to present a global view of the architecture of our system, on this slide, you can see all the names of all the people involved in this project, both from BSc and the Europeana Foundation, in terms of technical contributions, as well as support and communication. Okay. Excuse me. So let me briefly introduce the global architecture, and then I will give the floor to my colleagues who will explain, will focus on some highlights, technical highlights in this global architecture. Okay. Our system consists of different modules whose joint purpose is to generate, on one hand, good quality object labels, as well as rich descriptions for the visual content of the paintings. Okay? So here, what you can see here is the object detection module that is basically a neural network that uses the COCO pre-trained model and applies transfer learning. To do this, we basically extract additional classes from Wikipedia Commons that have to do with people in art pieces, things that you don't see again in everyday life, dragons, swords. Well, maybe you see a sword here and there, but it's not very common. Zucchettos, halos, things like that, right? And on the other hand, we filter out anachronic COCO classes. We filter out things like cell phones, motorcycles, and things like that that would not appear in paintings before and including the 18th century. As a result, we generate a set of candidate labels for each bounding box that is detected. Okay? This is the first module. The second module is the visual relation rule module. So based on these candidate labels for the bounding boxes, this module applies, well, goes through several steps to basically analyze all pairs of bounding boxes and generate candidate visual relationships between these boxes. Okay. Excuse me, I forgot to say, this module will be presented following this global architecture by Artem Reshetnikov. Then the visual relation rule model is going to be presented by Cedric B. Now, from the visual relationship module, we got candidate visual relations between bounding boxes. We also have the labels, the candidate labels for the objects. And this is the module that is based on natural language. It's a natural language-based model that, what does it do? It takes object labels and visual relation labels and combines them to, well, applies a technique that Joaquim Moret will explain that has to do with filling the blanks in statements to predict missing words based on the context, and as a result, improve the label that is generated. For example, instead of a person, if I have a person with like wearing an armor, I'm going to say, well, this is a knight, or a person on a horse is a rider or a warrior. He's going to explain this module. So as a result, you generate refined object labels. And it's a start. These two modules, the visual relation and the natural language model, are a start to generating descriptions, okay? Image descriptions. Why, excuse me, why are we doing this? Usually tools take pairs of aligned image and descriptions, apply deep learning, and generate new descriptions. As I said, we have little data, not big data. So it's smaller than we even assumed. So we need to look at these alternative methods to make up for the lack of data, for the lack of aligned image and description data. In any case, we also develop, I don't know if this works. Yes, okay. So this is all together, plus another little box here, which is not connected yet. This is a description classifier. It's basically a module that takes a whole lot of descriptions and tries to decide which of them are worthy of the caption-like description name. They're not things about, you know, the painter's personal life, where he painted, what medium he used, but only things that have to do with the visual description of a painting. Okay, so we're also working on that, and one of the challenges is how to put this together to reinforce each other and correct each other and do a good job in generating descriptions. I hope I didn't go very much over my time, and I'm giving the word to Artem Reshetnikov. Thank you very much.
Okay, just a few seconds. So basically right now, we are talking about the first and the basic step of the project. It's object detection. And I will explain some insights about object detection and how we implemented and what we did. So I guess remote control doesn't work.
Hi, Artem, do you need support? Oh, no.
No. Yeah, right now it works. So as Maria Cristina said that we faced several challenges, several issues in applying the state-of-the-art models, deep learning models of object detection in cultural heritage. And here you can see example of state-of-the-art models. Basically, it's a model trained on the COCO dataset, and you can see the results of object detection. Instead of crucifixion, it detected giraffe and the car. Taking into account these issues, these challenges, we decided to train our own model. And yes, of course, there is some kind of problems, and we try to solve it. The idea was to use the transfer learning and to prepare our own data set for train the object detection model. Basically, we understood that we will not be able to collect thousands and thousands of paintings, manually label it, and then train the deep learning model. That's why we decided to use the transfer learning, and we used the model based on the COCO dataset as a transfer learning, and we create our own dataset. Right now, you can see the data sources where we extracted the data. So basically, the main one was Europeana collection. A part of it, we used several open data sources such as Wikimedia, Wikicommons, Wikidata, and all of this stuff. We used Wikiart. We used some images from COCO dataset, and for sure we used the images from different museums of and of course the web gallery of art, because it's one of the biggest art collection in internet. What we have for now, basically right now our model is able to detect 69 classes. Our dataset contains 8,000 images, but we are in the process of collection the data, and I guess we will be able to achieve 10,000 images in like a couple of months. Right now, the dataset already labeled, manually labeled, and it's in the Pascal work format. I mean, it's more technical information, but if someone will be interested in it. And we use the mask RCNN architecture. So basically the idea of using the mask RCNN architecture is to be able to detect masks in the future. So right now the model is able to detect just objects. Here you can see the list of classes which model is able to detect right now. So there are classes, there are animal classes, there are classes of like specific objects, there are classes of like persons and related to the people, and basically I have to mention that right now we are in the process of improving the final list of the classes. So basically I'm sure that we will increase the number of the classes in the future. At the end of my presentation, I will share the link with you where we have the small demo in Google Colab, and you will be able to find the list of classes there just to be able to understand what kind of objects our model can detect right now. So here you can see examples. On the left side, you see the results of detection of the model based on the COCO dataset, and on the And on the right side, the results of our model. It was one of the first versions of the model, and we were so happy that our model we were able to distinguish between person and angel. And yeah, so right now it's kind of like normal for us already. Here you can see another examples. We worked a lot on defining the objects which will indicate the profession of occupation of the persons on the in the images. And here you can see the examples of mid-trained person, and based it on the analysis of the class, we will be able to understand that this person is Popo cardinal. I guess Cedric will explain how we will do it today, and I hope that you will find it interesting. Yeah, on the right side is just good example. I like it a lot, and I guess I like it a lot because it's from Museum of Barcelona. So yeah, that's all. Basically, we have the small demo for you just to be able to play with our model and to, I don't know, to try your own images for detection and to see how it works. I'm not sure, can I share my screen or not, Tamara?
Yes, you can share your screen, but wait a second, Artem. I just want to make sure that everyone can follow the presentation. There was one question that we might be able to answer quite quickly. What is meant by the difference between mask and object?
Okay. The difference between mask and object. Objects are normally detected by bounding boxes. So the bounding boxes is a rectangle where we have just 4 points. And mask is detection of the object pixel by pixel. So basically, if you would like to define the contour of the object and classify it as an object, it would be the mask. If you will detect as object inside of the rectangle, as it was on my presentation, it's just object detection. Okay. Cool. So yeah, basically, I will share my screen and I will show. Yeah, I will show you the demo and. Yep. Nope. Okay. Cool. So. I understand that it's not user-friendly because it's in Google Colab, and basically it's just a set of cells of the code, and people who are not so in technical.
Sorry, Artem, could you zoom in a bit? It's quite small, so just if you could zoom in once or twice. Great, that's better. Thank you.
Cool.
More, please.
So basically, it's just for people who knows the Python Google Colab, who is familiar with Google Colab. I mean, basically, if anyone wants to try it, feel free to do it. We have to execute it step by step, and that's all. It's nothing special. I did it already, so if you will follow the link, you will be able to open, and you have to execute it step by step. Here, I prepared the set of links for different images. And you can try all of them. And if you have your own images somewhere in the internet, you can put your own link. You can put your own link, and you can try your own images using our model for object detection. So here you see the results of the object detection. As you can see that our model can detect the crucifixion, can detect the halo, can detect the trees, banners, persons, of course. We decided to distinguish between person and prayer. So here you can see the bounding boxes for the prayer. Just to show you one more link. So we are downloading the image, and 3 are blind detection. Sometimes it takes time. Yeah, so you can see the centaur, you can see nude, basically here as well. We have false detection here. The model detected head, but I guess the bounding boxes should be here. So that's why we have the false detections. Feel free to use this Colab to try your own images, and in our document where you can post your questions, I would like that you shared your results as a screenshot or as images of applying our object detection model, and we would be glad to see your results, especially if it's not good, because we have to collect the data for improving our models, for improving our object detection model, and take into account that the model right now is in developing the process. If you have any questions, I can answer.
Yes, we're going to take more general questions later at the Q&A.
Yeah, for sure.
But thank you very much. And I'm also going to post the link to the Q&A doc again now, because that's where you can paste in your screenshots of the demo if you want to. Exactly. Thank you.
Okay. So who is next?
We are just waiting to get back the presentation. Thank you. And now it's Joaquin Maurice Lopez. Turn. Hi.
Well, sorry. Hello. My name is Joaquin Maurice Lopez. I'm computational linguist at the Barcelona Supercomputing Center. And I'm going to talk about the natural language processing role in this project, which is by now refining object class detection by using a language model. So in that case, to the left you can see a description of a photograph, when the description says that the image represents a person on a horse. So nothing happens, it's okay. But if we want to have a description of what is represented in the painting by Raphael, to say that it's just a person on a horse, it's not enough for us. It's supposed to say something more than saying that it's a person. We are expecting some information about if it's a warrior or not, it's a rider, or if it's a saint. And so when we are in terms of cultural heritage, the description or the specificity of the description is more demanding in that case. So the problem is that when you train an image descriptor with images, the current systems are trained with lots of photographs. But in the case of cultural heritage, we don't have so many images of knights and saints and dragons. So we have a considerable lack of data. We don't have enough image data to train the system in order to distinguish whether the person on a horse is currently a warrior or a knight or whatever. So in order to overcome this problem, we wondered, well, if we are relying on a model which is trained with with a lot of data, why don't we rely on a model which frames our thoughts and our way of seeing reality and seeing the relationships in cultural heritage? So in that case, we thought of, why don't we use language as a way of inferring a specific class? So for instance, if we apply what is called a closed test with the class person and the class crown, we can infer the class king and queen. And the thing is that if we have a lot of images of people or person, and we have a lot of images of a crown, we can infer king and queen, and it's not necessary to gather the system with lots and lots and lots of images of kings and queens. And the same for rider. We have lots of images of person, we have lots of images of horses, but so it's not necessary to train images labeled as rider, because this class can be inferred from this kind of inference. And this inference can be performed in a linguistic context, and in that case, in the closed test. The challenge is how do we perform the implementation of the computational implementation of the closed test? So in that case, we were thinking of using a transformer-based language model. Maybe you know what a transformer-based language model is. BERT-like models that they model the content or the meaning contained in sentences. So this model is able to predict the original value of a mass word. So the model, one way of evaluating the model is if the model is able to infer a word that is not there, it's masked, and according to the context you can infer it. So the thing is that the model is good if it can perform the closed test. The prediction is based on the semantic context, and the semantic context is provided by the other non-masked words in the sequence. So the idea is, imagine that we have the painting, the St. George painting. We have bounding boxes. One bounding boxes delimitates a person, a horse, sword, and a dragon. Okay, and not only do we have the bounding boxes, we also have the relation, the visual relation between them, in very atomic, in very simple terms. So in that case, we know that the person is on a horse, and we know that the person is with a sword. So if we put this visual relationship as a linguistic context to perform the closed test, and this is the idea. On the right, on the left-hand side, you can see how the language model computationally infers that a person on a horse is a, and among the possibilities, we choose the one which is semantically related to the subject, to the main word in the context. In that case, we are choosing the ones that are related to a person. So horse is not taken, person is the same. So rider is a good choice, because a rider is a kind of person. And then if we replace a person for a rider and we put this in the same context, then we can infer a rider with a sword is a knight or soldier or warrior. So we are, in that case, we are specifying the class. So the same way, we even can infer that a warrior with a sword and a dragon is a hero. So, and this could be interesting because maybe we have the idea that the only person that killed the dragon was Saint George, but there are others. So in that case, we open the possibilities to have in mind other people who killed dragons, like Siegfried or Beowulf or Frodo. Beowulf, sorry, and so on. So in that case, it's how we can refine the classes by using the language model as a way of modeling how common sense or not only common sense, how the cultural heritage concepts are interlinked and are predicted and are known. So that's all. Thank you very much.
Thank you so much, Joaquin. And welcome, Cedric.
Cedric, we don't hear you.
Okay.
Hi, Cedric.
Yes. Yes, I think you can hear me now.
Yes, we do.
Okay, thank you. Okay, I'm Cedric B. Joined this project a short while ago, and I will talk to you about bounding box analysis. This is going to be a little bit technical. I'm going to show you things that are not usually shown in good company. Let's start. This is about inferring visual relationship between detected objects in images with complex scenes using bounding box analysis. And I'll start with saying that AI is not just about algorithms, it's about naturally coding algorithms, but also curating data, computing, and runtime is all about execution performance, usually forgotten by most users, but it's there. Exploiting algorithmic output is also very important, and interfacing between systems and between man and machine as far as user interfaces are concerned. I will talk about exploiting algorithmic output here. What do we do with images? We process them with, for instance, a region convolutional neural network, as Artem mentioned before. That means that we extract region of interest, features, and from that we can classify object labels for each region of interest, and we draw bounding boxes. We've seen that before. Good. But what's in an image, really? For us humans, there are objects which we label automatically according to our knowledge and our experience of the world. We also interpret the image by its composition, that is the relative size of the objects we can detect, the facial expressions, the body language, and so on. But to a machine, that same image is really this. It basically sees a plane with Cartesian coordinates, X and Y. The origin is in image processing always top left. And it sees a bunch of rectangles with labels. That's pretty much all it sees. So how can we exploit this to actually derive more information than just bounding boxes? We need an analysis methodology, and the first step of it is to parameterize images. The second is to pick criteria. And the third and fourth, which here will be confounded, are to elaborate rules in order to propose visual relationships. And I missed the arrow. The first step to parameterize images, I will go a little bit fast on this, is first to make every label unique. So if in an image we have 5 halos, as is the case here, we need to distinguish between them. And so we give them a unique identifier, which we tag along at the end of the existing tag root, which is halo in this case. The second thing we do when we parameterize images is to compute a center point for each bounding box. BBX means bounding box. And we calculate also the center point distance between every pair of bounding box found in the image. The third one is to, by using a grid, we map the image onto a grid 3 by 3, and we then can characterize object location according to the grid. So it's either center center or right center, left center, and you can see from this that the bird on top of the cross is top center. Next, we calculate relative surface area of each bounding box with respect to the image. So we can calculate how much space bounding box or region of interest occupies, and it will tell us something about, perhaps, if we're lucky, how important that region of interest is in the composition, the relative importance. Off is orientation and form factor. It's a very interesting parameter, which essentially goes between -1 and +1. When it's positive, it means the bounding box is vertically oriented. When it's negative, it's horizontally oriented. I'll give you some examples here. And without getting into the details of that, it's a very useful one, and we'll see it again in this presentation. And then the last two essentially are the bounding box overlap area, BRO, bounding box relative overlap. So it's a pairwise parameter. It's a parameter between any 2 bounding box of how much one bounding box overlaps another one. And the relative bounding box position is also a pairwise parameter. And it gives us information about, for instance, in the case of Halo 2, the figure of St. John on the right-hand side here, who is standing on his 2 feet, identified as prayer here at the bottom, prayer 1. But St. John has a halo, it's called Halo 2 here. And Halo 2 is, Halo 2's bounding box's center is north of St. John's bounding box's center. It's situated north of the center of the bounding box that delimits the silhouette of St. John. That's what our pause or the BBX relative position is. Good. I want to just insist on one thing. All the analysis that we'll present, we'll finish to present in the coming few slides, is based on pairwise analysis. Some of the parameters are essentially defined pairwise, that is between any two bounding boxes. But some of the parameters are also characteristic of any one bounding box, characteristic of a bounding box on its own. And I signify that here. Good. So now we can pick criteria. I will go a little bit fast. And basically proportions, that is proportions between objects that are detected. What is the normal proportion between a flower and a person situated in the same view plane in an image? It may be important, in particular, if you want to analyze depth of field in an image, in a painting. If you don't want to analyze depth of field, most likely you won't pick proportions as a criterion. OLOG is object location, we saw that before. Off is the parameter I just explained about orientation and form factor. It's usually very useful. Relative position is usually useful as well. Relative overlap between any two bounding boxes is interesting as well. But the trickiest, perhaps, parameter on which criteria are based for elaborating rules and deriving visual relationships from them may be the label. The label is, of course, by what it is, denotes an object. It names it. It names it as either a main topic candidate or not. Main topic understood as the main subject of the scene that you're analyzing, or the scene depicted in the painting. Some of the labels are possible candidates for main topic. They're basically all the labels that are instances of persons. So a monk would be a possible candidate for a main topic, an angel as well, a pope, any person instance. And I will jump to the symbolic content also of the label. It may or may not be, according to your specific domain, important to include symbolic content in your methodology. And in our case, in the context of sacred art between the 12th and the 18th century, it is important. Okay, the analysis methodology now centers on two toy examples of how to elaborate rules and propose visual relationship. Imagine you have two bounding boxes, a large one, BBX1, and another one, bounding box 2. If bounding box 1 is crucifixion, if the label is crucifixion, and that bounding box is aligned along the vertical direction, and I introduce another logical block here in that rule, and bounding box 2 is the label crown of thorns, and it overlaps with bounding box 1 in the way that is showed here on the schematic, and is in the upper region of bounding box 1, which is the case here on the schematic, and the pairwise proportions between the two are more or less respected, then crucifixion, which is an instance of person in this particular context, because if you talk about crucifixion, it means that there is a person crucified on a cross. So crucifixion implies person. Then crucifixion person is Jesus Christ, because usually in the context of sacred art representation, the only crucified person who wears a crown of thorn is Jesus Christ. And the second toy example is based on the same bounding box 1 as before, and it has a third one, bounding box 3, which when it is a bird and is situated north of crucifixion, that is on top of it, in the sense that we understand, and baseline 3, which is the baseline of bounding box 3 here in the schematic, is above top line 1, that is the top line, the top edge of the bounding box 1, then crucifixion person is also Jesus Christ. And that's where the symbolic content of the labeled bird is crucial, because it symbolizes the Holy Spirit. So is very much domain specific in this case. Okay, and now I will give you, to finish, a real example. It's a rather simple example. We have developed code and a methodology that applies to much more complicated examples. Here, the detected objects are person 1, crown, person 2, and halo. So person 1 is the large box here. Person 2 is the one that delimits the infant Jesus Christ, carried in arms by the Virgin Mary. The crown is the crown that crowns Virgin Mary, and the halo is also superimposed on the crown. The reference objects, that is the main topic as analyzed by the code, by the bounding box analysis, the main topic is person 1, according to several criteria of size, of centrality on the grid, the 3x3 grid I mentioned before. This bounding box of person 1 is identified as being the main topic. It also, the code also identifies that person 2 overlaps with person 1 and is part of the main topic. And in technical terms, we just say that person 2 is part of the cluster controlled by person 1. Cluster because it overlaps in a significant way. In this case, because it overlaps 100%. 100% of person 2 is within the box of person 1. And the visual relationship in key value format are the following. The person 1 plus crown 1, part of the analysis, these are the two bounding boxes that overlap, so they form together the key, and the value of this visual relationship is person one stands. That's what we deduce or we infer from, rather, from the analysis. Person one wears crown. Person one coiffed with crown is either king, queen, or Saint Mayor within the context of sacred art and iconography for the period of time that interests us. And the second one is person one plus person two. And here, again, the code infers that person one stands as before, fortunately. Person two is child, infant, dwarf. And you might smile at this, but it means not all at the same time, even though child and infant may be confused or conflated. Dwarf certainly wouldn't, but it's just that the code is not capable of distinguishing between dwarf and child. It's just a bounding box whose proportions with respect to the larger bounding box of person one and its configuration tells us that this may be a child or an infant or a dwarf or a midget or a person that is smaller than normal. Normal being an adult size person with a lot of inverted commas. Okay, oops. I just realized that using the wheel on my mouse also allows passing slides.
Actually, Cedric, we have to get to the end of your part, so maybe we can get to the end.
I finished. The last sentence I wanted to contribute to this is that child, infant, dwarf, person, oh yes, I'm sorry, is here. Person one holds person two is basically what is inferred and is a seed for caption or description. Thank you.
Thank you so much, Cedric. And actually, I would like to jump in with one question because it's a direct question to what you presented. And Clemens Neudecker asked, do you use bounding boxes or also polygons? How do you deal with overlapping regions by a Z-index?
I don't use polygons. I could be using them. I haven't gotten to that, but it would be exactly the same treatment.
Thank you so much. And now we head over to the next presentation.
Do you hear me? I hope.
Yes, we hear you.
Okay, so I'll try to be really brief to make up a little bit for time before giving the floor to Albin Larsen, who's gonna talk about the last technical talk. You've listened to some highlights of our work so far. We've obviously we've heard about most of the challenges we've met so far. Some of them we expected since the beginning of the project, some of them were unexpected. And this is a bit of a summary of what we had to, and we have to fight with and resolve. And some of them are on the good track and some other ones are things that we would actually like to ask help with. And this is what Albin's talk is about, crowdsourcing. So one challenge that we've met, everybody talked about it, is data collection. We don't have a lot of images of some of the classes that we're trying to recognize. Well, you can read on that slide. I'm just going to go quickly. There's a lot of variation in medium styles between painters, but in any case, there are not so many paintings anyway. And it's not like I can go off and make another painting as if I took another picture to increase my data set. Okay, so the second kind of issues are mostly technical. Since we have a small data set by data mining standards, we need to use complementary techniques to deal with anachronisms and detect actions and objects that are unusual in everyday life. Third issue, metadata. So we talked about data, and now we talk about metadata. So if we want to use deep learning to generate labels, to generate visual relations, to generate descriptions, we need to have metadata. We've been supplementing the lack of metadata with the techniques, with some of the techniques that you've listened heard about just now. But we would love to have more metadata for training purposes. And lastly, and very importantly, there's the challenge of evaluation. Well, we want to generate rich quality metadata, but what is a good quality metadata? What defines quality? Are there different kinds of qualities for different users? What is useful to the user? So these are all issues challenges that we're having. We've made way in some of them, and we're in the middle of discussing, for example, evaluation. Okay? What is the best thing to do in terms of evaluation? So while we try to do a good job with little data rather than big data, at the same time, I want to single out one of the tasks that could make a big difference for us in terms of metadata for training, but also for evaluation, which is crowdsourcing. And with this, I will give way to Albin to talk about crowdsourcing. Thank you very much.
Hello, everyone. I'm Albin, and I work at Europeana Foundation in the R&D team. And I'm here to show a couple of examples of crowdsourcing, both in this project and outside this project, as well as a couple of concepts for how we can gather this type of data that we're looking for. And let's see if I can be given control here.
You have to go to view options.
Yeah, I've done it.
Ah, sorry. Well, click on the slide.
I am now in control. All right. A couple of examples of crowdsourcing projects in cultural heritage, or at least partly in cultural heritage, would be Crowd Heritage, Suniverse, and Micropasts. And a couple of quick things we often see around crowdsourcing. First of all, it's about setting up controlled workflows or microtasks. And the previous projects are great examples of that, where cultural heritage institutions or professionals set up very small tasks which users can complete easily. And this is in contrast to like open projects like Wikipedia, iNaturalist, OpenStreetMap, which doesn't have this idea of ever being completed and where the user sets their own goals. Another thing we often see in crowdsourcing projects is a long pattern of contributions. So we see a couple of users contributing a lot of data, while some more casual users do less. And usually we try to optimize crowdsourcing toward that power user, which just does such a lot of work. And something else we often see in crowdsourcing project is some type of reward system. At one end, we have the type of reward which user get used by an edit counter or seeing them complete something. On the other hand, we have got things like gamification and even money rewards. So to move on to the conceptual ideas, one thing that we could get with crowdsourcing would be visual relationships. And I think this set of glass plates really illustrates what we're after. For example, we can see frogs sitting on a stone, and we see the bounding boxes here. And we need to know the relationships in between those. And to some extent, we can do that with machines, but we also need to confirm this and so on. So in the wild, we got a couple of examples of crowdsourcing, not necessarily of only visual relationships, but also of other types of relationships. And one of these tools that does it in text would be Regnito. We see here the first image is a great example of this, where a famous rune inscription connects two people by the relationship saying that one of them is the father of the other one. Another example of this, which is actually an example of a visual relationship, would be from Wikimedia Commons, where this person, Tove Alexandersson, got a bounding box, as well as its gesture or pose that are running. So this is an image within this bounding box depicts a person which is running. So concepts that we could apply for this project would be to give a user two bounding boxes and the semantic labels or some person, and give the user the option to select the relation, or even switch the place of the labels. So person, relation, horse, and so on. Another thing that would be great to crowdsource would be description. And it's not very common actually to see descriptions being crowdsourced. We often see existing descriptions being translated, or we see transcriptions rather than true descriptions. One example actually is again on Wikimedia Commons, where you can actually submit captions. And descriptions is a rather tricky thing, because a good description is not necessarily good for everyone. So to crowdsource this, not only do we need someone putting in a description, but we might need multiple people putting in descriptions and voting on them. So in this screen, you might be able to see that next to a couple of example descriptions, which are just dummy ones, there is a small arrow. So the users can actually vote for the best one. And through that voting, or entering a new one, or improving upon authors, we can actually reach some type of consensus. Another thing we've seen a lot of today would be bounding boxes. And here we have actually created a prototype crowdsourcing tool. And this is very interesting actually, because it lives in between this type of open project I talked about, like Wikipedia and so on, and their actual crowdsourcing project. So this is because we use open vocabulary or Wikidata. So instead of just tagging these 69 tags we got in the project, or labels, classes, you can actually select any entity in Wikidata. So a couple of challenges that has just been noted around this small demo with quite a few users would, for example, be the selection criteria. How do we select the best images, both for the AI part and for engagement? Those are not necessarily the same. We might have a selection of images we decide to include in this experiment. It might be more engaging for user, but not as important for training the AI models. Another one is just reaching quantity. How can we have enough people engaged with this? Another thing that becomes a problem, because we're using this open vocabulary, is granularity. So someone might need to decide to be very specific. They doesn't just say it's person. They want to say which person it is. So they decide to annotate that this is this person. And because we're using Wikidata, this is not much of a problem, because we can just look at what type of entity it is and then interfere that to our own semantic vocabulary. Another problem is completeness. So we don't really have that state. When is an image tagged enough? Because again, we're using this open vocabulary. And when is a tree, and when is a tree just a part of a forest? Another thing that is really hard is consistency. How do you actually label something with a bounding box, for example? What's actually the scope of the object? So here's a screencast of the tool we have so far worked with. We can see someone selecting something from an open vocabulary like Wikidata here, selecting hat. Here, creating bounding box for the hat and going on to next. And you can actually try this out. You can do it during the discussion or save this for later. This URL is also in the discussion document. And with that, I would like to leave to Maria Cristina. Thank you very much.
Thank you very much, Albin. I think we ran a little bit over time. So before we go to the Q&A session, I just want to comment on the next steps. Again, very briefly. Evidently, we're working on improving the current methods, both for tagging, like labels for objects and visual relations, and for description generation. And we're also working on improving the little box that you saw in the general architecture, which is the description classifier, trying to extract from a big body of text about arts, which are possible descriptions, rather than other things that are not about visual content of the images. Okay. Another step, deploying enrichments that we're generating and implementing a search and browse functionality. I'm not going to go into details. Another one is directly related to what Albin was talking about, sourcing more data, metadata, in principle metadata, both for training and for evaluation. And then finally, we need to do an exhaustive and quantitative evaluation of everything we've done. We are continuously evaluating, but we need to sit down and decide what are the criteria that we want to use, probably more than one criteria to define what are quality enrichments for us. And we also have a few experimental steps. We are looking at generating a knowledge graph for this, for cultural heritage, at this point for the scope that we're looking at, which is mostly iconographic images, but go beyond that. To use the second step, the second idea would be to use this knowledge graph and domain axioms and try to infer new things, new labels, refined labels for the objects, and either refine or generate relationships based on these axioms and the knowledge graph. These are experimental, as I said. And lastly, we want to try to see how far we can extend the scope of these methods, to see how well it works for other type of paintings that were not the main purpose for our methods currently. And with this, I give you the floor, Larissa, for the Q&A session. Thank you again.
Thank you so much, all of you, for this great presentation. And for those of you who didn't know it, actually, today is St. George's Day. So we're right on time for not only this project, but also for a great Q&A. And I want to thank each and every one of you who have left their comments and questions in the Q&A doc and also in the chat. And I think we can, yes, thanks for sharing the link again. And I'm also going to share it again in the chat. So I think we might start with a more broader question, which is about how did data selection actually work in the project? Why did you, for example, use mostly religious motives? And how do you encounter the issue of possible biases in the data? Now one of you has to take the step of taking this first question. Who wants to go first?
Okay, so I'll take a little bit of the question. We're not looking at religious paintings only. We're looking at mythology, iconography, and it is true that we have decided on a subset to focus on the subset, which seems to be a very large subset of paintings in this period. Obviously, in the 18th century, it's not quite the same as in previous ones. So just to say that they're not religious, the scope is not religion, is mythology. And I don't know if Artem can explain maybe a little bit about the selection, if the question is also about the technical part. I'm not sure.
Yeah, regarding this question, I'm not sure that, I mean, basically, yes. Right now, we used mostly the religion paintings in our presentations, but the whole data set contains a lot of different images, different paintings from different sources, and the religious one is just a part of that data set. So basically, yeah, I guess. And Maria Cristina said that, yes, we used these examples just as a part of the methodology, because we have, for example, classes from Greek mythology, we have classes from Romanian mythology, and so basically we focused on paintings in general, but we decided to limit the to have the time period from 12th to 18th century, and basically we are not in the limit of topics of the paintings.
Well, and in fact, in order to select the classes we are working with, we took the Bikini Commons taxonomy, and we were gathering the classes, the most popular classes that were there. And for instance, with classes like men with instrument, people with instruments, and then we took this taxonomy and we took the classes, and of course the most of the paintings that were linked to these classes have mythological and religious topics.
Thank you very much.
So we took the taxonomy as a baseline.
Thank you so much. Actually, those of you who are interested in this the specific topic of bias in AI, I would also encourage you to register for the next session in the EuropeanaTech and AI webinar series, which will be with the Cultural AI Lab, and we are going to focus on that topic as well. We had one question that came up during the presentation of Cedric, and that was about Mary, because Nancy asked, why is it indicated that one person stands while Mary is seated? No, that person one stands while Mary is seated. And Cedric, you already reacted on this in the chat, so I wanted to give you the chance to also answer it in full length.
Yes, it's actually a very good question, good catch. Can I have control of the presentation, or is it not possible? So I can show something. Okay. Yes. Okay. Okay. Right. I'll go back to slide number 54.
There's quite a lot of background noise right now.
Okay. All right. Overshot here. Okay. That was the image. Oops. I overshot again. Okay. That was the image that caused a question to be asked, which was actually very good. The Virgin Mary, by the way, I want to thank Martina Bagnoli for helping us trace this representation to the Virgin Child from the Historia Anglorum by Matthew Paris in the British Library. I didn't know, I looked for it, but I couldn't find the reference. What comes out of the bounding box analysis is that the Virgin Mary is seated. That the Virgin Mary person one stands here on the left-hand side. And the reason for that is contained in the following slide, which I didn't show for lack of time, and it wasn't essential, is the calculation by the code of the orientation and form factor is 0.29. It doesn't, it's not much of a reason, but the criterion that is by default applied to all the bounding boxes as far as their OFF parameter is concerned is that if the parameter has a value greater than 0.1, then it means that the person is standing on their 2 feet. And if the value of the same parameter is less than minus 0.1, then it means the person is lying full length, lying horizontal. And in this case, the value of the parameter is 0.29, and the code made a mistake at inferring that the person stood, whereas in fact it is seated. The only way out of this bind, of this problem, is really to detect the throne behind the Virgin Mary. And from the overlapping throne and Virgin Mary bounding box, deduce or infer that Virgin Mary is actually seated. That would be the absolute only way with bounding box analysis to counteract this failure. Right now, we don't have the class throne or seat as a piece of furniture, and so we're not able to detect the throne behind. There's another thing that that didn't appear here, and people might have noticed, is that among the detected object there is a halo, and the halo isn't part of any visual relationship, whereas the crown is. The reason for that is the overlapping region of the halo with bounding box person 1, Virgin Mary, is smaller than 0.5 of the halo surface area. And the criterion that is used generally for the whole data set we have is that for overlap to be detected or to be understood as meaningful, the bounding box relative overlap must be greater than 0.5. So that's easy to fix. That's very, very easy to fix. But I thought I would actually leave it there so you would have a sense of how kinky this thing can be sometimes. It can be a little bit tricky. Thank you.
Thank you so much, Cedric. Heading over to the next question of Emmanuel. Would this model work with engravings of the same images or sculptures of the same period? And I'm thinking I'm asking Artem here, right? Or
Artem, go ahead if you can. I don't know whether the question was about labels or visual relations, but Artem can start.
yeah,
We don't have a lot of time. Yeah.
Yeah, basically, I mean, in our dataset, we have examples of paintings and we have the photos of sculptures as well. And I guess our model will work for both cases because we had some kind of like lack of data for some classes, and we decided to use all possible, all available data in that moment. But our purpose, our objective was to build a model for object detection in paintings. So basically, I assume that the precision of the model will be less if we will apply the model for photos of the sculptures. But I mean, yeah, it will work. It will work.
Thank you. I actually have a question, maybe representing the cultural heritage professionals who also joined this session, because we were really glad to see that people with really varying degrees of experience with AI have joined this series and the session in particular. So you've talked about the challenges that come for a research project and an AI and machine learning project such as yours. And what do you actually would wish from cultural heritage institutions concerning how they share their data to actually enable projects like this one?
Well, whoever has the good quality data and metadata and it basically has a fortune. So in this kind of projects, the most straightforward approach is if you have a lot of data sitting around and a lot of metadata sitting around, then you can do a lot of things with it. And this is what we innocently believed at the beginning of the project, and it did not turn out to be the case. So we would be thrilled to work with any cultural institution that can help us with either with data or metadata. There are some museums that have their digitized collections together with keywords, and some of the keywords, for example, are relationships. So this is extremely interesting for us because we can possibly use it for evaluation. Because one of the big problems, as I said, that we're having is evaluation. We generate things, but somebody has to tell us whether we're doing a good job or not. And this somebody has to be a person. So one way is to do crowdsourcing, as Albin was suggesting in one of his slides, to let's say, to show an image with one or several descriptions or labels generated automatically and have people choose between them or add their own. But another way to do this is if institutions already have some sort of annotations they could make available, that would be of enormous value to us. Also, we're very interested in connecting with museums and to see whether, you know, some of the stuff that we're doing can be applied to their work if they're interested in the future, look at the enrichments that we will be obtaining and take advantage of them. So we are basically technical people. This is one of the first times for me to work in a cultural heritage project. I'm very technical. Kim comes from humanities, so he has more experience. And it's a very exciting field and a lot of interesting possibilities, but we need data, metadata, people to help us with evaluation and people interested in what we're doing.
And I think that's why such events and also such platforms such as the Europeana Network can be so important to actually reach out to those different communities, because I really hope that we cultural heritage people didn't scare you away now. I've learned a lot and I hope that's also true for you. But remember, this was only the kickoff, the first session of many more to come. If you want to dig deeper into this topic of AI and machine learning in the cultural heritage sector, head over to the link that I've shared in the doc. And register for the next webinars in this series. I want to thank the speakers. Thank you to Barcelona and thank you to Europeana to have joined us in the session. It was really interesting and intriguing to listen to your research. Stay safe, everyone, and we are going to share the recording of the session as soon as possible. Thank you and bye-bye.
Thank you very much. Happy St. George's Day.